Good morning and welcome to my Wireshark tutorial class. What I'm going to show you within this tutorial are tricks that I use to decode Samsung Office Serve traces to be able to detect one-way audio, no audio, and to get just a general understanding of the type of traffic that the system is being exposed to. Um, the items that I'll show you within this tutorial are just tricks that I've picked up along the way. There may be better ways to do those. There may be easier ways to do those, but this is what I use, and I wanted to pass that along to anybody that may also want to use those. So with that being said, here we go. First thing we're going to do is go ahead and open a trace file. And I'm going to go open this OAS Capture 1 because I've already pre-screened it and I know it does have good examples of one-way audio. So right now all we've done so far is opened a raw capture file. One thing I do want to point out is that I've modified my view from the default view and I've added the source port and the destination port. This makes it real easy for me to be able to see where the traffic's coming from and where it's going to, because most often what I've experienced within tech support is that the traffic is being blocked based on the port number. So for me, it's very critical to be able to see what that port number is. In order to make that kind of modification, if you wanted to do the same thing, you can just right click here at the top on the title bar, and we're going to go down to column preferences. And once you're within column preferences, you'll see that I've added two new fields, source port and destination port. And I use the unresolved names because a lot of times if the port matches something that's industry available, then it'll put the industry name up there for that port, such as 3389's remote desktop. Well, Samsung may use 3389 for something else, and it's just more confusing if you actually have it resolve the name for purposes of just decoding Samsung traces. So with that being said, I just leave the ports as unresolved. So feel free to do those. Add those to your screen. I would highly recommend it. I also show VLAN IDs, which is another piece of information that I like to look at to see how the audio traffic is flowing. You can apply those and just click OK. Since I already have them applied, I'm going to click Cancel here. So once I get a trace, the first thing that I like to do is go to Statistics and go to Summary. And this will give me a summary of what I'm looking at. So if the issue was reported to have happened on March the 6th at 12:14, then I can take a look at the time here that's captured in this summary and see that 12:14 does fall between the first and last packet. If it falls outside of this time period, I'm not going to be able to see it within this capture. So that's always first and foremost the first thing that I check is, does the capture cover the period in which the problem was reported? Okay. Once we're past that, then the next thing I'll do is I'll go ahead and take a look at the endpoints. And what this does is it analyzes all the traffic and breaks it down and gives me a list of everything that I can expect to find within this trace. On the first screen here, this is Ethernet, so the hardware address, so MAC address. And I see that I do have some Samsung gear here and a Sonic Wall firewall and a couple of other items here. The ones I'm going to be most interested in are going to be the Samsung gear and potentially the Sonic Wall firewall. So that breaks it down by MAC address. You can also look at it by IP address, see the same information, and by if there were TCP packets in this trace, it would show the TCP here. There's only UDP packets. So here I can break it down, and the important part about this screen is that I can see the audio ports that are being used, and for every even port that's in the 30,000 port range, then like 30,042, 46, 50, 52, each one of those represents a new call on the MGI card. Because the way the MGI card numbers the port is every time you make a call, the increment goes up by 2. Now, you will also see accompanied with The even ports, you'll see the odd ports. The odd ports are going to be the RTCP traffic. At this point in this tutorial, we won't cover any information regarding those ports, but we will concentrate on the even number ports 30,042, 46, 50, 52, 54, and 56. Okay, so what this is telling me is I was able to capture MGI traffic. I do see the ports here. Back on the Ethernet screen, I do see that we have Samsung gear, and I can even go as far as to match the MAC addresses to the actual pieces of hardware to confirm that that's actually what I wanted to trace. Okay. So I'm going to pretend with this particular trace that I wasn't provided any background information and that I was just going to scan the trace to see what I could find wrong with it. The first thing I'm going to start with is I can see the 30,000 ports being used, so I know I have MGI traffic. So what I'm going to do is see where is the first occurrence of an MGI call. The reason I'll know that is it'll be the lowest even number 30,000 port range port that I can find. So going back to statistics and go to endpoints, I'm going to go over here to UDP and I'm going to sort by port number, and then I'm going to scroll down, and so we're at 29,000. The first one that I can find is 30,042. Okay, so I'll go ahead and close up, and here I can type in a filter to filter out all of these traffic. Down here we know we have 70,000 packets, so I'm going to go ahead and type in a filter of so the filter to view just the UDP traffic for the first call that we're going to put in is going to be UDP.port equals 30,042. I'm going to apply that, and it's going to filter out everything that's not related to this particular call. The first thing that I quickly glance to see is that I see that the destination port that we're speaking with is 9,000. 9,000 tells me that we're dealing with an ITP key set or an SMT key set. And I do see that I see two-way traffic because they're going back and forth, back and forth, back and forth. And so this particular call looks good from just a general overview. A couple of other tricks that I can do is, if you see right now it's trying to decode this traffic as IPv4, which is fine, but I'm also gonna further in or make the protocol a little bit more specified, and we're going to go to RTP. So down here we're going to select right click and select decode as, and I'm going to change this to RTP. Okay, and apply. And now you will see that we're looking at traffic that's a little more oriented for the voice side. So if I look down here in the more specific detailed view, as we're looking at the packets, then I can see different information: the source port, source address, source MAC address, destination port, destination MAC address, destination port. And I see that we're using G711 codec. So a lot of good information can be found after I decode it as RTP traffic. Okay, so another method that we could do to look at this stream a little bit further is I'm going to right click on the RTP traffic, and I want to say, I apologize, we're going to go to telephony, and we're going to go to RTP, and we're going to go to stream analysis. And what this does is it uses some built-in tools to kind of evaluate the RTP traffic and let you know, if you're experiencing packet loss or packets out of order. And for this particular tutorial, what we're concentrating on is we just want to see if we have, dropped packets, or if we're looking at a one-way audio scenario. Right here, we can see lost RTP packets, and the stream is 0, so that's very good. The other thing that I can do from this screen is we're going to go ahead and go to player and click decode. and it will actually show me the channels are set up. If there were no audio packets whatsoever for one side of the conversation, one of these two screens would not be here. What we're looking at is we're looking at the send side and the receive side. So for this particular one, if the source port is 30,042, that means that this traffic is the transmit from the phone system to the endpoint. And since in this particular case, in the bottom section here, the traffic is destined to 30,042, that's inbound to us. So that's our receive traffic. So you've got your transmit and receive traffic here. These particular streams, what we're seeing is while the streams are set up, the channels are set up, the ports are set up, the networking piece is set up. Either nobody's speaking or it's on mute. Because all of the channels are set up, there's just no conversation being held. As we go through, I'll find one in just a minute to show you that actually does have an audio conversation in it. And if I wanted to, I could go ahead and hit play, and you can actually play the call back as long as they're not using secure RTP. Okay, so moving on. So we see that we have both sides of the conversation. There's no packet loss. So for this particular call, we are going to say that we do have two-way audio. Okay, so since the ports will increment in by 2, then we'll go ahead and skip to 30,044, and this will show us our next phone call off of that particular MGI card. Looks like there's no traffic available for that particular call, so we're going to go ahead and skip to 30,046. Okay, and here we're seeing the same thing. We're seeing 30,046 to 9,000. So based on the ports, I could verify this using MAC addresses, but just based on looking at the ports, I see a conversation between an ITP key set or an SMT key set and one of our MGI cards or an OAS card. So this one looks like we're good here. We have two-way audio. We see send receive traffic. So we're going to continue to move forward to 30,048. No traffic available for that call, so we're going to go to 30,050. Okay, and here we are seeing one-way traffic. As you can see here, we have all the traffic headed to the 208 address, which the MAC address is being decoded as a sonic wall firewall. So from our MGI card to the sonic wall firewall, we're transmitting traffic, but this capture does not show any audio traffic coming back towards us. So I'm going to go ahead and decode this as RTP traffic, just as we did with the previous call. Apply. Click OK. Okay, so now we see that the codec is G711, and we still have all the information about the IP address. And now we're going to go to telephony, RTP, stream analysis. And if I look at player, decode, you'll notice now that I have audio. You can see that there's a conversation going on here all the way through the call. But if you notice, I only have one window this time. That's going to mean that I only have one side of the conversation. So this is a clear example of one-way audio. Well guys, this tutorial is running a bit long, so I'm going to go ahead and cut it short there, but just wanted to kind of go through some of the methods that we use in tech support to decode the Wireshark traces that you send in. I look forward to putting some additional videos out. If you have any suggestions, be sure and just let your tech support representative know. Have a good one.